Quadratic functions. So first let's define a quadratic function. F of x equals ax squared plus bx plus c. Or we could write it in what's known as vertex form, where we factor out the leading coefficient, complete the square, and we end up with a x minus h quantity squared plus k. So let's define the vertex. The vertex is the turning point on the graph of a quadratic function. It's located at the ordered pair h comma k if in vertex form, where h is negative b over 2a and k is the corresponding y value, so f of negative b over 2a, and that comes from ax squared plus bx plus c. The definition of the axis of symmetry is the vertical line x equals h, which again is negative b over 2a through the vertex. So here on the graph of x squared, we have the axis of symmetry. What that does is, no matter where the parabola is, when you fold it across the axis, the graph is on top of itself. So we've already talked about f of x equals x squared. So now we just have the vocabulary term of the vertex. That's the turning point. So remember, if it's a low turning point, it's a minimum. It's a high turning point, it's a maximum. And we've got the axis of symmetry, the domain, the range, increasing, decreasing. And when we're graphing, if the leading coefficient is positive, the parabola opens up, it's positive, it's smiling. If the leading coefficient is negative, the parabola faces down. The y-intercept for any function is f of 0, and the x-intercepts for any function is set the function equal to 0 and solve for x. And with a quadratic function, that would obviously lead to a quadratic equation. And then also we need the vertex when we are graphing, and we can calculate that with negative b over 2a. So let's take a look at the function negative quantity x minus 3 squared plus 16. So this function is already in vertex form. So remember that the x value of the vertex, it's always set up as x minus the number. So h is 3. So the x-coordinate of the vertex is 3. And then the y-coordinate of the vertex is 16, positive 16. So that makes the axis at x equals 3. Now the leading coefficient is negative 1, so it's negative. So that means the parabola is going to open down. The y-intercept is f of 0, so plug in 0 for x and we get 7. And the x-intercepts, we can use the square root property to solve for x. So we end up with x equals 7 and x equals negative 1. So when we go to the graph, we plot the vertex at 3, 16. We can sketch the axis of symmetry and plot the x-intercepts, plot the y-intercept, draw the parabola through those. Now the range is from negative infinity to 16, so we have a high point, so the greatest y value does include 16. We're increasing, the function is increasing from negative infinity to 3. So remember that increasing and decreasing are written in terms of the x-axis. So decreasing from 3 to infinity. And we would say that the function has a maximum at 316. So remember, a maximum is a turning point where the immediate adjacent points are lower than the turning point. So it is a hill. It's the top of the hill. Okay, in applications of quadratic equations, we introduced projectile motion. And so in this example, and we got the function, just as a reminder, so g over 2 t squared plus v0 t plus h0, and g over 2 is negative 16 feet per second squared. So in this example, we're going to find the max height, which is now we know that that is the vertex, since we have now studied quadratic functions. And this object is launched from the ground with an initial velocity of 160 feet per second. How long until the object hits the ground? So the negative 16 is g over 2. So if the gravitational constant is negative 32 feet per second squared, then g over 2 is negative 16. And then v0 is 160. So the coefficient of t, so in terms of the quadratic function, v0 is b. And h0 is 0 since it's launched from the ground. So we know that the maximum height occurs at the vertex. So h equals negative b over 2a. So negative 160 over 2 times negative 16 is 5. So the time at which the object, the projectile, reaches the maximum height is 5 seconds. So in order to find the maximum height, we need to calculate, oh, I accidentally wrote f. Let me change that. We need to calculate s of 5, so the height when time is 5. So we plug in 5 for t, and we get 400. So the maximum height is 400 feet, and it occurs when t is 5. And then let's answer that question about when the object hits the ground. So the object would hit the ground means that height is 0, so s equals 0. And this we can solve this by factoring. So factor out the GCF of negative 16t, and we're left with t minus 10. So there's 2 values for t that make this statement true. T equals 0 makes this statement true. Now that would be our launch. So when time is 0, that's the launch time. And then the factor t minus 10, that's when we solve that one and we get t equals 10. That's when the object hits the ground.